is on slope-intercept form. We're going to do the same sort of examples where we kind of have the slope and intercept given to us to write in that form, and then from 2 points. We're also going to look at a graph. Okay, so let's talk about slope-intercept form. We've discussed slope. We've discussed intercepts. So let's kind of put them all together. Oh, that wasn't bad. And more specifically, that's not the way I want to do it. That's a positive slope, so I need to go upwards in my rise. Okay. So we can use rise over run to find our slope. But to find the intercept, there's multiple intercepts here. We are focusing on the y-intercept, which we're going to call the variable b. If you had the x-intercept, it's the variable a. So x is a, y is b. That way it stays in an alphabetical order. Okay. But slope-intercept form looks much simpler than point-slope form. So there you have it. You have your slope and your intercept. Not just your intercept, but your y-intercept. This one, I would have to say, is much more commonly used than point-slope form, but you do need to be able to do both. So slope-intercept form is this guy right here. Let's look at some examples. So write the equation in slope-intercept form. I would write it in slope-intercept form anyways, because that's what it gives me. There's no reason to make it complicated. Okay. If this asked me for point slope form, I'd have to do a smidgen more of work, but not really. But if I'm given a point and slope, I'm probably going to write point slope form. If I'm given slope and intercept, I'm going to write it in slope intercept form, unless your math problem tells you to do something different. So yet again, it's asking for me to do something specific. I'm going to go ahead and write the formula or the equation every time to ingrain it in my brain. Do we have M? We sure do. Right there. Do we have B? Yep. B is the y-intercept. So all I have to do is y equals 3x. That's a -2 for that y-intercept. So it's going to be -2. And there you go. Doo-doo. Slope-intercept form. Now, how could I use that to graph? Well, I know the intercept is -2. I know that's the y-intercept. So that's right here. I know the slope is 3. That means the slope is actually 3 over 1. So I'm going to go up 3 over 1, find my second point, and voila. Y equals 3x minus 2 is now on a graph. You do the same thing with point slope form. Now, what happens if you're not given the slope and the intercept? Well, you just have to find them. Okay, this tells us we have to write it in this form. That means we have to find M and we have to find B. Well, we know how to find slope, right? Just use our slope formula. I'm just going to kind of work through this one now that y'all have seen it a few times. And we'll go ahead and label all the different parts. And again, feel free to pause whenever you need to. So I just found that my slope is -5. I'm going to double check. Did that kind of fast. All right, looks good. No negatives, pretty straightforward. So if I go ahead and plug in my slope here, I still have to find B. Like, how do I find B? I could graph it, but that doesn't work every time, and that's a lengthy process, especially if you don't have to graph it. What you can do is you can just pull one of your points and plug it into this x and y value and do a little bit of algebra to figure out B. Could I have chosen this second point? Yeah, I'm going to choose the point that's easier. And 2 and 1 are smaller numbers than 1 and 6. So I'm going to go ahead and choose the first point. So what is the y value? Well, it's 1. What is the x value? 2. Now I have a two-step equation. -5 times 2 is -10. To isolate the variable b, to get rid of a -10, I need to add 10 to both sides. 1 plus 10 is 11. That cancels to be 0, and that leaves me with a positive b, which is b. So now I know m and b. Again, pause, rewatch if you need to. I know m, the slope. I know b is my y-intercept, and there is my equation. I'm going to graph this one to show you guys on the coordinate plane with the xy's there. Right? So if you don't have the y-intercept, you have to plug in one of the points into the equation, solve it, and then plug it back in. Okay, so let's see that this works. My y-intercept is 11, which is right up here. And this is not necessarily the best way to do this, but just to show an example, this would be fine. Normally, you'd want to extend the graph out correctly, not just wing it. And now we know the slope is -5 over 1. That's down 5. 1, 2, 3, 4, 5. Right 1. And because I am not using a ruler and drawing a straight line is impossible, let's check that it actually goes through these 2 points. Does it go through 2, 1? Yep, actually I got that dead on. Does it go through 1, 6? Yep. So I can verify with a graph if I'm just, taking notes or doing practice problems that it's actually correct, that I've got the correct slope-intercept form by doing a quick graph and then checking my original points. But I could not rely on this by just freehanding to find the correct intercept. Okay, that's important. Solve it algebraically. Let's look at another problem. So we're given the graph of a line now. We just need to write it in slope-intercept form. Slope-intercept form. Do I know the slope? Well, I've got a graph. I can figure it out, right? Let's do that. I'm going to just do rise over run. These are small values. The grids go by ones. I can simply find the slope is the rise, which is 3, over the run, which is 2. I chose those 2 points because they were points on the line that were closest. I could have chosen this point up here. That's another point on the line. The slope is constant on a line, so you can choose any 2 points to find the slope. I chose the easier points. And sometimes you see it too late, and that's fine. It will give you the same value when you simplify. So slope is rise over run. So slope is 3 over 2. Now we just need to find b, and b is the y-intercept, which is -3. I'm not going to write -3. I'm going to write subtract 3. And there you go. It's the exact opposite of what we did in the last graph. And that's, again, this slope-intercept form is going to be your more common equation of a line, especially when you're talking about graphing values. One more. This equation of a line does not look like either of the ones we have seen. This is not point-slope form. It's not slope-intercept form. Our job is to make it slope-intercept form. That way we can easily pull the slope values and the intercept value from it. And to do that, we just rearrange the equation. I've always taught equations like this, so just bear with me. If you don't need the upside down t, don't use it. If it helps you, fantastic. So we want that equation to end up looking like this equation. We need y by itself. So first, let's move this x term to the other side. That's a positive 4x, so we're going to subtract it from both sides. 4x minus 4x cancels. That positive 5y stays. Equal sign stays in position. And these two guys, they're unlike terms. You cannot combine those. A lot of students want to leave the 10 first, and that's fine. But if you notice in your equation over here, the x term needs to come first for us to have the correct slope-intercept form. So I will go ahead and put the negative 4x first. That means this positive 10 turns into a plus 10 behind it. I don't have this equation still. I can't just say, oh, the slope is negative 4. No. Slope only comes when your y term is isolated. So we still have to divide everything by 5. Because 5 divided by 5 cancels. That's going to just stay negative 4/5 x. Don't divide that in a calculator. Most of what we're going to do will be done by hand. You still need to have a calculator on standby. But for the most part, we're going to leave it in fraction form. 10 over 5, that's just 10 divided by 5. That's 2. So there you go. We now can see our slope is negative 4/5, and our y-intercept is 2. That could help us graph it. That could help us compare one line to another. We could get the real-world values and compare real-world aspects now too. We are going to continue doing lines in the next lesson.